Good morning, folks. This is indeed Catherine. I don't have a head at all. At least I didn't on my generator, hello? On my generator videos. What I've got here is an old vintage type valve or vacuum tube radio. And sometimes there'll be times when you want to test a piece of mains equipment, and which could be deadly, so you've got to be very careful. And in a full workshop you might have a thing called a variac. And variac's also a gentle way of starting valve radios if they haven't been turned on for a long time. Or vacuum tube radios. They cost hundreds of dollars. I haven't got one. I've got a homemade thing called a dim bulb tester. Now, I must say I'm running this through one of those 4-way plug boxes, because that's got a little wee miniature circuit breaker thing in it that trips out if there's any kind of short circuit. I've also got this thing, which you can buy at a hardware store. Some extension leads have them built into them. In New Zealand and Australia they tend to be called an RCD, residual current device, or an ELCB, earth leakage circuit breaker, and in West Australia, because the government there is mentally defective, they call it a safety switch. This will turn off so quickly that it is almost impossible to electrocute yourself. Now, my homemade dim bulb tester is basically an extension lead cut in half, and this is in the middle of it. So I plug that into there. So it's still turned off at the moment. Now, we've already examined this radio. We've checked it for any obvious defects. We've checked the cord for any obvious safety problems. We've looked inside it to make sure there's no dead mice or anything like that. So, and this is one a friend helped me test this at the workshop a few days ago. Now we can plug this into our dim bulb tester, which is still turned off, into the safety switch or the RCD. We make sure it's turned on at about half volume or 3/4 volume. And you need to have some old-fashioned type tungsten light bulbs. You cannot use the modern, very energy efficient LED bulbs. You cannot use the recent ones from a couple of years ago, the CFLs, the compact fluorescent lamps. You must use the old tungsten, the bulbs that aren't energy efficient. You start off with the smallest one you can get. They don't sell these much nowadays. You might have to hunt them out because they're energy inefficient. These little 15-watt ones were sometimes sold for fridge lights, light in the refrigerator, or in a sewing machine. So we put that in there. Put that on our fire resistant metal tray. I've got a couple of other light bulbs here. So this is a 15-watt for starters. This is our homemade dim bulb device. We've got low power and full power. So it's made out of a switch, and we've got a voltmeter here. So I'm going to power up the RCD, the earth leakage circuit breaker. The bulb comes on. That's not the full brilliance of a 15-watt bulb, because the electricity has to go through that before it can go through the radio. This radio at full power would be about a 60-watt radio consumption. 40, 60, something like that. But it's being restricted by the bulb. Now I can actually see on the voltmeter there we've got about 70 or 80 volts. Remember, the mains in Australia, New Zealand and Pacific countries is 230 to 240. So we've only got about 70 or 80 volts. If this light was to be the full brilliance of a 15-watt bulb, there could be a dead short in here. There could be a dead rat in there. There could be some wires burnt out, something like that. Okay, that's fine. 70 or 80 volts. We'll turn that off. We'll take this bulb out. We'll replace it with the next size up. That's actually a 25. We power on our earth leakage circuit breaker again. And we've got a bit more voltage now. That's about 110, 120 volts. Now the radio is turned on about half or 3/4 volume. 120 volts. Now that is not a full 25-watt brightness, so that's fine. We know that there's quite a bit of resistance in the radio. We know there's not a dead short in there, or a dead rat, or whatever else. We turn that off. Oh, it was just warming enough to hear some crackles start to come through, and that bulb's actually starting to get a bit hot now. We'll now put in a 40 watt bulb. So again, a 40 watt bulb's got less resistance, more electricity can get through to the radio. And it had by then a minute or so to warm up. Obviously that's not 40 watts worth of brilliance. I don't know if the camera picked it up. Initially it went a bit brighter and then it dimmed down. And that's of course as the various circuitry, capacitors and things in this radio. Ah, there we go. It sounds a little bit sounds a bit awful and sabo, so to speak, but we got about 150, 160 volts. Now I've got another bulb here, and that wasn't on for long enough to get hot. This one's a 60 watt bulb. So in round figures this will, well, it'll let more electric through. Okay, so we're now up to about 190 or something volts, just a whisker under 200 volts. And very dim. If that was very bright, it would be a problem. Now we'll keep that turned down, we don't want any copyright issues. And now we can flick this to full power. Goes up to about 230, the bulb goes out. Radio's coming up much louder. I'll now turn that down for YouTube copyright reasons. And yeah, now we're at about 230 volts. And that's it. If I extended the aerial wire out a bit, no, this one doesn't have an aerial wire. This is the ultimate. I have a feeling it's from 1957. Now, the other thing I should mention, when you do this, you need a pen and a blank piece of paper, because what you're going to then write down is the radio, the date you tested it, how well it worked, and I'd already done this for this one earlier. Yeah, so this model came out from 55 to 59. It had, unlike a lot of our radios, have a piece of wire hanging out the back. This one has a ferrite rod antenna, so it doesn't need it that. Yeah, but you may need to turn it around to get the best reception. Obviously it's AM only, but there we go, that's going great. And of course it's sitting right next to the TV screen, so that's where a lot of interference is going to come from. If we turn this back onto low power, you see the bulb comes back on, because we're running the power through the bulb before it even gets a chance to get to the radio. So I've actually got two more radios here to check, and we might give them a bit of a go. I will turn this off. I'll take out the bulb. I'll unplug the radio. And that is the end of the first video.